Hi everyone and welcome to our virtual Biopolis lab. Today we're going to teach you a little bit about acids, bases, and the pH scale. And we put together some kits for you so that you can do the lab from wherever you are. You can follow along with this video. I'm going to introduce the Biopolis team first really quickly. I'm Julia.
Hi, I'm Kaitlyn.
I'm April.
I'm Lily.
I'm Sarina.
I'm Kaylee.
I'm Rebecca.
So we hope that you are all doing well in these trying times and that you and your family and friends are staying safe and healthy.
So now Julia will be teaching you guys about acids, bases, and the pH scale, so make sure you pay attention and follow along on your worksheet because it will be very important to the upcoming experiment.
Hi everyone, it's Julia Picker from Biopolis, and today I'm going to teach you a little bit about what we call acids and bases. Let's get started. Okay, so I want you to think about what you think about when you hear the word acid. I don't know what you've already learned in your classes, but when I say the word acid, you might be thinking about either a science fiction book or film you've seen where acid is being shown dissolving metals or being used as a chemical weapon. On the right side of the screen, you can watch acid being poured on a sponge. See how the acid dissolves away the sponge? That's pretty cool. However, most acids do not do this. So I also want you to think for a moment about eating a lemon, an orange, a lime, or a grapefruit. What do those fruits taste like? Well, one thing they all have in common is their sour, tangy taste. That sourness is actually due to the acidity of these fruits. But what does that mean? Let's find out. So what are acids and bases really? The chances are you've heard a little bit about both of them, and I want you to keep in mind some of the things we talked about in the previous slides. As scientists, we study acids and bases as part of the field of chemistry. So this is where it gets a little bit complicated. Do not worry if you don't completely understand this slide. However, if you have learned about atoms, ions, and molecules in your science class, then you're already an expert. So I want to first talk to you a little bit about atoms. So an atom looks like this, and atoms are basically the building blocks of everything. So if you were to zoom in really close to anything, this pen, my hand, you'd see that it's made of a ton of tiny little things we call atoms. They're like the Legos that combine to make everything. So we could take a little tour of what an atom looks like. So the center of the atom is called the nucleus, and in the center we have little particles called protons and neutrons, and orbiting the nucleus we have particles called electrons. So when we have more than one atom combining together, we call it a molecule. Now sometimes atoms and molecules can carry an electric charge, and this electric charge comes from either losing or gaining electrons. So we have a neutral atom right here. This has no charge. But what if we take this electron right here and we boot it out? What we get is we get an atom with a positive charge, and this is what we call an ion. So see, it's missing its electron right here, and so now it becomes an ion. So what do ions have to do with acids and bases? Well, an acid is any solution that contains a high concentration of hydrogen ions. So in the picture to the right, we see a neutral hydrogen atom, and orbiting the center or the nucleus is the electron. But if we yank the electron away, we get a hydrogen ion. Now, if we have a solution with a ton of these hydrogen ions just packed together, we call that an acid. So when there are a lot of hydrogen ions in a solution, like shown below, that solution is acidic. The more hydrogen ions the solution has, the more acidic. So I want you guys to think back to the taste of lemons. The concentration of hydrogen ions is actually part of the reason it tastes sour. Now with bases, it's just a little bit different. Instead of having a lot of hydrogen ions, it actually has a lot of hydroxide ions. And a hydroxide ion is what happens when we put an oxygen atom and a hydrogen atom together. So you can see right here, here's the oxygen atom, here's the hydrogen atom. Put them together, and that's a hydroxide ion. And it has a negative charge, so that means it's also an ion. And when we have a lot of them packed together in one solution, like below, the solution is basic. So remember that when we were talking about acids, we were talking about a high concentration of hydrogen atoms. Here we're talking about a high concentration of hydroxide atoms. So that was pretty complicated, but if you can remember this, then you'll be fine. If something has a lot of hydrogen atoms, we call it acidic. But if it has a lot of hydroxide atoms, it's a base, or what we call alkaline. And you can see the little illustrations that I showed you before. So here are some common acids and bases. So on the acid side, we have these things that sort of have a sour taste, including oranges, lemons, limes, vinegar. And I don't expect you to have tasted bleach. Please do not eat any bleach. But bleach is also acidic. Bases, on the base side, we have dish soap, do not drink that. Baking soda, do not eat that pure. And milk. And what's funny is there's actually one thing that is neither acidic or basic, and that's water. And incidentally, your blood is also neutral. So how do we measure whether a solution is acidic or basic? So we have a way of doing that, and we use what we call the pH scale. The pH scale measures the concentration of hydrogen ions in a liquid. The higher the number, the lower the concentration of hydrogen ions, and the more basic the solution. A lower number means a lot of hydrogen ions and therefore acidic. Something with a pH of 7 is neither an acid nor a base. We call that neutral. And you can see here on our little diagram some of the common things that you might find around your house and how acidic or basic they are. So again, at 1 over here, that's the most acidic it can be, and that means that there's a lot of hydrogen ions in that solution. Over here at 14, that means there's very few hydrogen ions and actually a lot of hydroxide atoms, which makes it alkaline. How do we test the pH of a solution? Now, I was telling you a little bit about tasting solutions, and if something is sour, that normally means it's acidic. But what if there are solutions that we absolutely cannot taste because that would be so dangerous? Well, we can use something called litmus paper. Litmus paper turns a certain color in order to indicate whether the liquid is acidic or basic. Usually, if we put the litmus paper in and it comes out a reddish color, that means the solution is more acidic. Whereas a bluer color means indicates a more basic solution. Well, that's the end of our virtual lesson on acids and bases. I hope that you've learned something today, and if you have any questions, please email us at ccabiopolis@gmail.com. We'd love to hear from you. Bye, thank you. In the next portion of this video, Kaitlyn and Lily are going to guide you through the experiment. Make sure you gather all your materials and listen carefully.
From the materials list, gather all of your supplies and keep all 6 of the test tubes closed until you're ready to begin. And we're going to work with 1 sample at a time. So in this demonstration, we're going to be using beakers, but you will have test tubes. And we're going to be testing Capri Sun, but in your kit, you will be given lemon juice. So carefully open the lid of your test tube, and then taking 1 pH strip, you're going to dip it into the liquid and wait for a color change.
Okay, ready? See how it changed color from the yellow of the strip and now it's red? And so according to this scale, if we look at the pH scale, we can match this with a pH of around 2 or 3, which is acidic, as you learned.
Exactly. And we're going to be doing the same thing for the base sample, but instead of using lemon juice, you're going to be using baking soda and a new pH strip.
So this is actually like a baking soda solution. So what I did, and what you'll be getting is water, and we put powder baking soda in and like kind of mixed it together, which is what is like, that's what a solution is called. And so as you can see, there's like small sort of bubbles in it that just indicates that we put the baking soda in. And so this is a base, and we're going to take another pH strip and we're going to put it in. Whoa! See, it turned from the yellow to like a blue-green. And then going back to the pH scale, it looks like it's around a pH of 8 or 9, which, as we learned, is basic.
Yeah, and you want to keep track of your results by writing down what the pH was in your data table and taking note on observations on like what color your strip changed into.
And then there will be 4 other test tubes that you'll receive that will be labeled 1, 2, 3, 4. And these are mystery liquids. And so what your experiment will be today is you'll be, first of all, looking at the color of the mystery liquid, maybe smelling them, just to sort of guess what these liquids are, and then writing those down on your worksheet, and then using the additional pH strips to test the pH of the mystery liquids. And then once you know what the pH is, you can look at the list of potential liquids that we give you on the worksheet, and then you can either change your guess or hypothesis or keep it the same. So the experiment is we want you to guess the identity, guess what the mystery liquids are, using pH to identify.
Exactly. And then once you're done with testing the mystery liquids, you're going to have 4 pH strips left, and you could use this to test anything in your house. Like, for example, you could test soda, or you could compare bottled water with tap water, see if there's like a difference in how acidic it is, and make a hypothesis about this too. Have fun exploring.
Yeah, definitely. Okay, thank you. Bye.
Bye.
Now, before we sign off, I just wanted to have a quick word with you guys about the importance of becoming scientists, especially during times like these. Now, during the coronavirus epidemic, there are a lot of people who still have to go to work, and scientists are some of these people. They are currently working very, very, very hard to find a vaccine, which is like a medicine that protects you from getting sick, as well as a cure for the disease. And now more than ever, it's so important that you all keep exploring and doing science experiments. And maybe one day you'll be the one to cure a disease or find a vaccine that saves everyone. It all starts now.
We really hoped you had fun learning, and thank you for listening. If you have any questions about anything, you can always email us at ccabiopolis@gmail.com, which is also on the worksheet.
We hope you guys are all staying healthy, happy, and safe. See you next time.
Bye.
Bye!